Hey, I'm Steven. I work in the product team at Anthropic, and I help out with a lot of what we do for public sector. And usually when I'm giving a talk like this, I spend a lot of time talking about who Anthropic is, how we grew up, what we do, what we care about, the fact that AI progress is really accelerating right now, and why that makes the stakes kind of high right now. I'm thinking today, I might be able to assume some of that knowledge, especially in this room. So with your permission, what I might do is skip some of the sales pitch and the background. And I really wanted to think about what would be most useful to you all practitioners. So, I was off by one. I want to start with a story. So early in my career, I was working in a research lab, and this was way before AI transformers existed. We were building this sensor system to help end users in the field understand the environment before they had to go there. And this was mind-blowingly sophisticated stuff, like novel signal processing algorithms, new math, tons and tons of time spent in the field ground truthing to make sure what we were predicting was actually going to work out. It was like real novel, interesting science. Late in the program, I was showing it to one of these end users who might use this thing. And this guy was so patient with me. He had better things to do with his day. But I was really excited. I was new in my career. I was explaining all the cool science we had done. And he goes, "Wow, that is so cool." And then he pauses for a second, like he's trying to figure out how to say something. And he goes, you know I could pay a local like $10 and get that same information, right? Whoops. That was early in my career. It was 20 years ago, and I've spent most of my career working in and around public sector organizations, and I've watched that same mistake change costumes over 20 years. I'm inside an AI lab now, and I've been there for a while. I've watched us make plenty of our own mistakes too, and I've caused a lot of them. So I was thinking the thing that might be most useful for you all is some practical advice on how I think about incorporating AI into these high-stakes workflows, most of which I've learned the hard way. I should mention, by the way, that everything I'm about to say comes with the assumption that what you're building has high consequence and high stakes. Like, I don't need to explain the stakes to you. You guys know that, obviously. What I can do is shed some insight on how we're thinking about this as we're trying to incorporate AI into workflows that really matter. So the first thing, and I should preface this by saying I've got deep respect for my friends and colleagues at OpenAI. I think the ChatGPT launch taught the world about AI, and it also taught the world that that blank prompt chat box is AI. So I think ChatGPT both popularized AI and it taught everyone that anchored that UI pattern. So when someone thinks like, man, I really need AI, what they're thinking now alongside that is, I really need a chat interface. And what I want to propose to you is that that's a category error. So I think chat was, and really is, this amazing demonstration of the full range of capabilities of a large language model. But I also don't think that needs to be the form it takes in production. So I see a lot of agencies now and institutions, both in the government and outside, with teams building more and more of these chat boxes. And that feels like product work, right? Like, you've shipped something, you've shipped the chat box, people can type into it, interact with it. I also think it's what people ship when they don't fully understand what their users' workflow needs are. So in a way, I think when you ship that, you're also shipping product discovery to your end user. And so you're saying, like, hey, here is the entirety of the model. You go figure out what it's good for. So I also think that's inviting your users to have that blank page problem that, when you open Word and you have the blank page. They go like, hey, cool, what am I supposed to do with this thing? And it's too hard, I'm busy, I'll figure it out later. So what I would propose instead is, let me twist the knife one more time in the chat box. I also think when you ship these, you're throwing away the one thing that you all have in spades that I have to work incredibly hard for. You're really close to the systems that store the important information that power the mission, and you're really close to the workflows that power the mission. So like, you might know what the classification guide has in it just innately. I bet people here like know what the sitrep template is and like how to go find all the data that goes into it. Somebody else here might know like the 92 steps it takes to fill out or adjudicate a claim once it happens, right? Or what the isms tripwires are. So let me end on this with a positive version of this. Work backwards from the mission of the user that you want to empower. And to actually be a little bit more nuanced on that message, I think if you embed the AI, the large language model, in the context of their existing workflow, that existing workflow does a lot of the explaining and helps to solve that blank page problem. So taking us, for example, we included a large language model in the terminal, and it turns out developers sort of knew what to do with that innately. That's Claude code. What I would propose to you all is embed a large language model in the claims adjudication workflow, and I bet the person working in that workflow has a pretty good idea what to do with it. So lesson 1 here is work backwards from the mission of your user. Your advantage is the data knowledge, the workflow knowledge, and reconsider whether you need to build one of those boxes. All right, the next thing. We're shipping something soon. It started as a stray thought while I was walking my dog around town on a Saturday. I spent all day Sunday building a prototype, and that was not even with the best model that's available to you all today. That prototype worked well enough by the end of the day Sunday. It showed enough of the end-to-end workflow and all the corner cases and demonstrated this thing tangibly that Monday I walked into work and went like, hey guys, I think we should ship this thing. And we are. That's not because I'm particularly good at my job. I'm not Bruce. It's because what used to take weeks now takes a day. Building got cheap. So prototypes used to take weeks and weeks and weeks. You would write a spec. You would go get some engineers excited. You would get a designer. You'd figure out all the workflow corner cases. And that you would spend a lot of very expensive time, potentially weeks, before you could get to something tangible that actually demonstrated how something's going to work in practice. You can accelerate a lot of that now. And a lot of other speakers on this stage have been talking about how you should ship more and maybe plan a little bit less. And they do it much more articulately, and they've been doing it for much longer than I have. And waterfall is thankfully mostly dead. There's an AI twist on this, though. I think that with large language models, the cost of being wrong early is approaching 0. So what I mean by that is you can build 5 prototypes and kill 4 of them. I also think maybe you don't need a roadmap. You need a Sunday. I also think this is what planning, or this changes how I think about planning. So I'm thinking a lot more in demos. I'm thinking a lot more in terms of demos and a lot less in terms of really detailed plans. So lesson 2, shipping is getting really fast. Use it. Oh, I should mention, there's a failure mode here. Something I've seen is that I've seen a lot of organizations accidentally ship like 5 different versions of the exact same feature to customers because they didn't have time to coordinate with each other. They were shipping so fast, they didn't coordinate. And so I think this comes to something that's changing about product craft in the age of AI. And lots of people have mentioned how product roles are sort of converging. You've got PMs shipping code. You've got a lot of engineers coming up with product strategy, really insightful product strategy insights. You've got designers, lots of designers at Anthropic ship code too. And that can be chaotic. There is, however, this really core product leader skill, I think, which is being able to create clarity from ambiguity. And I think that gets even more important when you can ship so fast. So all that chaos of designers shipping code and engineers coming up with product strategy, that can start to work if you're making sure that everyone has the same shared context, everyone has the same shared goals and same understanding of the strategy. And when they do, they can start to prioritize autonomously. So, like I said, lesson 2 is building got cheap. Use that fact. So I told you you should build 4 things, kill 3, ship 1. I thought I might talk about how we decide what to do there. If you've been working in the public sector space for any amount of time, or GovTech, it will not be a surprise to you, and probably not controversial, when I observe that requirements are awfully popular. Here's the thing, though. Large language models are non-deterministic. So if you ask a model the same question 2 or 3 times, there's a vanishingly small chance that you'll get the same answer the same 2 or 3 times. And that means you can't write, shall respond correctly in a requirements doc somewhere. You just can't test every possible input and output of the model under every condition. Actually, if anyone in the room has been a manager before, you might notice that humans have the same property. That though, even though we've been hiring humans for a while, that concept that you can't possibly test every input and output under every condition is like a terrifying concept, probably justifiably, to acquisitions folks, to security, authorizing officials, and ISMs, and to program officers. So I thought I'd share a simple version of what we do when we've got a behavior that we really care about understanding in more depth. So what I'm going to tell you to do is write a whole bunch of prompts, say 20 or 50, maybe 100, that really demonstrate the range of the behavior that you're interested in. That's step 1. Step 2 is then you, not the AI, write down a version of what good would look like. What's the best possible answer given this prompt? And then you see how the model does. And honestly, grading by hand is great in the beginning. So let's take a toy example for a second. So say you're writing something to help with FOIA redactions. Maybe prompt 1 is a document with a social security number like smack in the middle of it. Good looks like the same document without the social security number. Your grade is whether the AI got there by itself or not. That's an easy one. Maybe your next prompt is a document with a phone number spelled out in words, like, hey, Bob, call me at 1234567 in words. Again, good is same document that's stripped out. Write a bunch more of those. I gave you some simple ideas. You'll get to judgment calls. And then see how the AI does. So you're writing, in other words, a model eval. You might have heard of that term, right? If you've been in this room before, if you've listened to some of these other speakers, I would probably put money on the fact that you're instrumenting delivery at this point. So you're probably tracking time, metrics like time between failure, deploy frequency, and things like that, right? That's been around in this space for a while. What I want to challenge you to do is to extend that same instinct to models. So what I want you to do is start to think about instrumenting model behavior too. I mentioned model evals. I saw a couple people nod. If you've been in this space before, in the AI space, you might have noticed that people like to come up with incredibly complex ways to do things with AI. Model evals are not unique in that regard. And there are some extremely sophisticated tools, but honestly, you would be shocked how far you can get with a spreadsheet. So I would suggest starting there, and it's really useful. So here's the thing about those 20 prompts. Coming up to that empty chat box, you can't write 20 prompts for an empty chat box, right? It's like 20 prompts about what? I would argue that the moment you can write those 20 prompts, that's the moment you scoped a workflow. And if you can scope a workflow, that means you found the end user, you found the operator. And that means you started working backwards from the mission. So evals are generally useful. I also think they're a really good forcing function. It's how you go from, hey, here's some AI, to, hey, here's the job. And there's something I didn't tell you about that sensor system at the beginning of the talk. The program office loved that thing. They had bought a novel R&D line item, and we delivered a novel R&D line item. We built the thing that they and I were proud of. Maybe not the thing that would necessarily get used. And that wasn't an AI system. That was like well before large language models existed. But if it was, and if I tried to go write those 20 prompts, I couldn't have. Or at least not without finding the person who could have asked me, who could have saved me a whole bunch of time first. It would have forced that question. And I want to extend this eval concept one more time to high consequence systems. So I told you, right, to make a spreadsheet with a whole bunch of prompts capturing behaviors around a workflow, and that'll give you a number at the end. It'll be like, hey, 80% pass rate. And that's really useful if you're comparing models, different versions of Claude to each other, maybe Claude to some of its contemporaries. But it's maybe not that useful by itself. I think even more interesting in our space is what that 20% miss rate means. So it's a 20% miss rate on what? So if it's a 20% miss rate on a draft that human edits before it goes anywhere, maybe fine. If it's a 20% miss rate on a high-stakes decision that no one's going to look at before it's executed, maybe nowhere near as fine. And I think that's getting around starting to develop a harm model. And I also think you can't develop that harm model from a requirements doc. Like, it has to live with an understanding of the AI model, and it has to live with that end user who has to live with a 20% failure rate and know innately what that means. I also think that 20% is how you defend placement of AI in your systems, or defend placement of your AI system. So if you've got to that point, you spend time reading the failure transcripts, you've got this like innate knowledge of what AI is good for right now and maybe what it's not so good for. You've talked to users and you can articulate what that 20% costs. And that is how you have that conversation about like, hey, I know this is a high-stakes system. Here's why I trust AI in this part of it right now. So that's lesson 3. Build evals. They're a really useful forcing function. Here's another observation that probably won't shock the audience. Systems that last 10 years are like a short time in public sector. Like, who knows how long the B-52 is going to stick around? Its service life is probably going to be 100 years by the end of the story. So we're used to fixed platforms, and I think we're used to engineering around fixed platforms, right? I think AI is a complete shift there. It's the opposite. The substrate you're building upon is improving on a regular cadence, and it's improving exponentially. So here's the implication of that. I think that means you can ship something that works 65% of the time now, and without changing a single line of code, there's a really high chance that in a month or 2 or 3, that 65% goes to 85% with no work on your part. So I think there's 3 implications to that I'm still wrapping my mind around myself. The first is that, to the last slide, if you understand the failure modes, you can ship earlier than you think. And that helps you just validate whether this good idea you have is actually going to resonate. And when you do that, you can have pretty high faith that the performance is going to catch up. So thinking about ourselves again, like a lot of our most successful products shipped when they barely worked. And now they're institutions. The next implication of the substrate you're building on improving exponentially is that I've got this instinct where I hate shipping something at 65%. It just like harms my soul. So I've got this instinct to add a whole bunch of scaffolding. Like, oh man, can we add some retry loops? Can we like stack guardrails on top of guardrails? Here's the thing if you do that. Those take a long time to build, and they're probably tech debt by the time the next model comes out. A lot of the work we're doing now is removing things that we added early on because the model just does the thing now by itself. Third implication here, so I talked about how you can assume that the model is going to keep getting better and better and better underneath you. I think your instincts for cost should be the same. So I found that I can use more tokens now and more expensive tokens now than I think I can or should, because as fast as the models are improving, the cheap models are catching up on about the same cadence. So what I would offer to you all is every time there's a model release, for sure stand around like the Avengers screenshot, but I would also consider that like a signal to reconsider and think back about like, hey, what things that didn't work last quarter might be possible now? Like, are any rails you added obsolete? But also, what just works now? And a way to force that, I would, again, back to the evals slide, suggest you keep a tally of what's too hard for your product right now. Build an eval. and keep pushing it regularly and regularly and regularly. And one day, the thing that was just out of reach is going to work. And when that happens, you've got product work to do. Like it's time to go change the affordances for your user so they can go accomplish that workflow that was impossible yesterday. So that's lesson 4, design for the model getting better. All right, so I've told you that, hey, the thing you're building upon is going to accelerate geometrically, and that's horrifying. I've also given you the advice to work backwards to the mission and use the fact that building is getting really cheap. I've told you to build evals and use that as a forcing function. I've also mentioned that you need to design around the model getting better. So what do you guys build if the model is going to churn? I think you build the parts that are yours. The parts where you have an unfair advantage in domain knowledge about data or workflow, or an unfair advantage in go-to-market. So that's building the eval, the spec for what good looks like for this workflow. I think that's also building the encoded workflow itself. And selfishly speaking, that's why we made skills, and it happens to be an open standard. I think it's also building the connection to the data that matters. Similarly, that's why we made MCP, and it happens to be an open standard. Those things are model agnostic. They survive the swap. Like the eval doesn't care which version of Claude it's running on. I also think they survive the exponential. So I'll leave you with one thought. The mechanical parts of everything I just described to you all, the 20 prompts, you're writing an MCP server, writing a grader, that stuff is getting honestly pretty easy. And you can get help with those. I'll be around. The hard part, I don't think, is the mechanics. I think the hard part is knowing the mission well enough to write those 20 prompts. So I would suggest, go find that end user, go sit with the person who lives with a failure rate, who bribes the local for $10. That is still yours, and probably always will be yours. So thank you, and I cannot wait to see what you guys build.